Hi, Professor Caps. This is my lava lamp experiment from our advanced concept. We're going to make a lava lamp out of these ingredients: Alka-Seltzer, water, food coloring, and vegetable oil. Alka-Seltzer is made up of citric acid, sodium bicarbonate, and aspirin. I wrote down the molecular formulas because I was curious about those later. The components to the experiment have several different parts. There's a polarity effect evident in this experiment because the oil and water don't mix because the organic carbon chains in the oil are neutrally charged and do not attract to the overall positive charge of the water. So no bond attraction means no combining of the two chemically or physically. The food coloring, in this case, is a chemical water-based, and because of this, it also has an affiliation to attract the polar positive hydrogen component. So the food dye will adhere to the water. There's also a density effect in this experiment. Water has a greater overall mass and therefore density than the oil, so it will sink to the bottom with the oil floating on top. You can physically try to turn the water and oil into a mixture, but they are not insoluble, and so eventually, even if you heat the water, it will cool and they will separate completely. Alka-Seltzer, there's also acid-base reaction. Alka-Seltzer contains an anhydrous citric acid, which is an acid, and a sodium bicarbonate, which is a base. So when the sodium bicarbonate hits the water, it breaks down into bicarbonate and reacts with the water to give off carbon dioxide. The carbon dioxide is what makes the bubbles, the gas bubbles that float up to the top. And when they do that, the water kind of adheres, the water and the food coloring mixed kind of adheres to it, and it looks like little water droplet bubbles floating to the top. Once it gets to the top, the bubble pops and the carbon dioxide is released, and then the water bubble blob droplet drops back down to the bottom. So let's take a look at what it looks like when you actually do the experiment. You need to fill the water about a quarter of the way full. Get that. A little bit more. That's about right. And then most of the rest with the oil. I had a hard time finding the molecular structure for the oil because, as it turns out, it is quite a few oils mixed in, and because of the esteric acid in it, it's what hardens some of it into usable oils.
Too much. Too much.
Whoa, whoa, whoa. Too much. Well, you know, sometimes it happens. You can't see what you're doing. And that's all right. That's why I put it on wax paper. Because I figured that might happen. Okay, then we add a little bit of, I chose red dye. And we add, you can see the water base dripping back through the oil down to the bottom. Mixing with the water and combining with the water. Nope, it is sticking to the oil. That's interesting. Let's see what happens when we mix it later. Okay. Then take your limited reactant, the Alka-Seltzer, and you stick it in there so that we can have that bicarbonate water reaction. The acid base, it also says that the citric acid binds with the sodium bicarb once it's reactant in water. I didn't get to go too much into detail about that, and there it goes. So the reaction is forming on the bottom with the water and the red dye, and the bicarbonate and the carbon dioxide are released. Ooh, I'm getting good bubbles on this one. And it temporarily changes the density of the water when it adheres to it as a bubble and lifts it through the heavier oil, the lighter density of the oil up to the top. And the bubbles are released. And you get your lava effect. Okay, what's interesting is the red dye mixed with the water, but it's not really lifting with the bubbles. And I wonder if that's because I used a more organic red dye. But so what happens is that the Alka-Seltzer, the sodium bicarbonate, will eventually deplete itself. It's the limited reactant, and so it completely reacts, and once it does, the reaction stops. If we take the top back off, more of it escapes. That's weird. Why are they staying suspended? I gotta do more research now. But if you add more, the process will resume. It's kind of hanging up at the top, isn't it? Maybe I put too much oil. If you add more of the sodium bicarb, the reaction resumes because your water stays, obviously, at the end of the reaction. It doesn't go anywhere. And then you have a lava lamp. Oh, now it's working better. The red dye is adhering to the bubbles and lifting. But that's funny, it's some of it staying on top. And that's all I have for you. I'll attach the written work that I did also. Thanks so much.